Hello folks, welcome to a new video. So in the last video we discussed about the limitations with IP addresses. We discussed how as the number of devices increase in the world, the number of unique IP addresses that we can have is still some 4 billion sort of a thing. So we need to find a way to tackle it. We cannot assign unique IP address to every device that comes out. One solution that we discussed was to increase the range of IP address, that is by doing IPv6, but that wasn't really practical because for doing that we would have to migrate all the existing devices that are on IPv4 to IPv6, which would be a pain. So it's not that quite properly adaptable. Another solution that we discussed was grouping like devices together in a network and using one unique IP address for that network to identify that network. So basically it would be the case when like we discussed, there will be one gateway for a network and it will have a public IP address, and any device inside within that network will use that particular public IP address to communicate with the outside world, and they cannot use their own private IP address, and that need not be unique like among all devices in the world. So that's what we discussed. So basically what comes up here is yeah, so basically we can have one public IP address for one whole network to communicate with the outside world, and that's it. So by that logic, we will be grouping IP addresses. We'll be grouping devices together to reuse the same IP address so that we don't run out of them. So grouping is a solution like we discussed. Grouping devices together within the network and so on. So in that discussion, something called NAT came up. If you remember, we talked a bit about attackers, but not much. So we'll go dive deep into this in this video. So what is NAT, what it's used for, and everything. So NAT basically refers to network address translation. Network address translation. It's very literal. It's what it says it is. We'll get to that once we understand how it works. It will be very obvious. So yeah, let's say we have this network here. Okay, so any private IP address, like if you see this sort of a thing, 192.168.10.10, that sort of a format, that's basically a private IP address. You cannot use that to communicate with the outside world. So that's one thing that you need to keep in mind if need be. But yeah, basically this is not a public IP address. Like if any router in the public somehow receives any IP packet with this, like they would probably drop it. So that's something that we need to keep in mind. And public IP address would look like this: 222.121, like random sort of a thing. There won't be any like 192.168 sort of a format there. So this is just like how it looks like. But basically what it is, basically all these devices will be represented in the outside world by this. That's the basic point that you need to keep in mind. No matter, like, you can add more devices here within this network, everything will be represented by this number, this IP address, when they communicate with the outside world. So let's say D1 wants to communicate with this server 150.150.1.2, anything. Like I wrote a random number there basically. So what it would do, like we discussed in the OSI model video, while communicating between IPs, there is one thing that we need to keep in mind. There would be a source IP address from where it came from, and there will be a destination IP address. So let's say this is the payload that it will be sending in the request. So the source IP address would be what? Source IP address would be this. This is the source IP address. I'll just write as source IP, and okay, this makes sense. So this is the source IP address, and destination IP address would be what? Destination IP address would be, like we discussed, this one, 150.150.1.2. So that's like the destination address that it wants to go to. And like we discussed, it's basically as simple as that. Like it's where it's coming from, the address, and it's where it wants to go. 150.150.1.2. Okay, so this is the whole packet that you'll be sending in the data for the communication purposes and everything. So we'll be sending this. Okay. Then let's see what happens next. So we talked about subnet masking, if you remember. So of course, like this IP, the destination IP, doesn't lie in this network. If you can recall what subnet masking did, what subnet masking would identify is if this device lies within this network itself. So that let's say device 1 wants to communicate with device 2, and it has a private IP of something like 192.168.1.3 maybe. So as you can see, like if it's a /24 sort of a subnet, if you assume, then it would be easily like first it would go to the router, and from the router it would check if it lies within my own network, and if it lies, it will route it there directly. So internal communication isn't that complicated. You'll just apply the subnet mask, and then if it lies inside your network, you pass it there. If it lies outside your network, we'll discuss that how to do that now. Inside one is pretty simple. So what if it lied outside your network? So here from the destination IP address, it's pretty clear that it's not inside the private network itself. So it needs to go outside. So let's say, so what it would do is, what router would do is, it would send request on D1's behalf. Okay. So it would send request on D1's behalf. So this packet is sent to the router. Okay. Then router would make a request on D1's behalf. So here the source IP would be different. Here the source IP would be this, so that when it send back again, then the router can collect it and send it back over. So the source IP is also different here. So this is the final packet. But one thing that you might be doubtful about is, like, let's say we send it like this. It comes back to the router with maybe the source source IP of this device and destination IP of this device. Now how would the router communicate, like how would the router pass it, how the router know which device made this request? Because if we don't keep track of it, it's lost. Because see, like the request was made from 192.168.1.2 to this IP address, this IP address. But since it cannot communicate it directly, like the router or the gateway would basically replace that IP with its public IP address. The request goes to the server responds back. Now the router has to pass it back again to D1, no? So as of now, there is no way it can do that, because like if we don't store it anywhere, it's not possible. So that's where NAT comes in. What NAT would do is basically what I just said. NAT would just maintain a table of whatever, like the request was. Let's say NAT would just maintain a table ki if a response comes from this destination IP, then send it over to this one. If a response comes from this destination IP, then send it over to this one. So that sort of a thing. So it's a table mapping sort of a thing only. Like let's say here is the NAT table for this router. So what it says is, like, while I am changing this here, but I need to take care of passing it back to D1 when I receive the data, right? So router is basically acting as a gateway only. That's all. It will be passing data from outside world to like the private network and vice versa. But here what we need to do is, while let's say from the beginning itself, D1 will send the data to router. Router will check if it's inside their own network itself by subnet masking, as we discussed. Here in this case, it's not inside the network. So what it would do is, it would make the request on D1's behalf using its own public IP address, because using this IP address we cannot communicate with the outside world. And then it would store an entry of it in the NAT record. Let's say 150.150.1.2 to this IP address. Request was made by 192.168.1.2. So that's what it will store. So what this means is, basically, if like this device requested to this destination IP, so whenever response from this comes up, route it to this device. That's all it means. So it's basically a proxy sort of a thing, if you can imagine, like in the real world itself. Like let's say what does what's the first thing that comes to your mind like with the word proxy? Like in colleges and stuff, if you like sometimes, let's say you don't want to go to class, you'll ask your friend that, okay, give the attendance on my behalf or give the proxy on my behalf. So what your friend essentially is doing is he's representing you to the classroom, basically from the attendance point of view. He or she can do it for multiple people also. So basically, if you assume this as your friend, and if you assume this as you, or this is like maybe some other people, maybe this guy is proxying for 3 people, like he's a pro. So basically, what he would do is, or what he or she would do is, and like they're basically representing you in the classroom, so that your work is done as well. Work as in getting the attendance, and like that's also sorted out, so that you don't face any issues. But you aren't actually there, like you aren't actually in the class, but your work is getting done. So that's what proxy means. So proxy is basically someone representing something on their behalf. So here also it's proxy. Like if you can assume a classroom sort of a scenario, let's say the server is the teacher, they are taking attendance, and these three people are into the router. They're like, okay, I won't be coming to class or whatever, like I cannot go there, so can you give my attendance on my behalf? So that's what. So this is called forward proxy. Like the whole thing that we discussed right now, this is called forward proxy. There is a term for it, of course, but it sounds very complicated, but it's very simple. Forward proxy. We'll discuss it in details in the next video. There is something called reverse proxy as well. We'll come to that. But essentially, forward proxy does is like basically something that represents multiple entities, that sort of a thing. Here, router is representing D1, D2, D3 to the outside world. Like any device within this network, if they want to communicate with the outside world, they will communicate with the public IP address of this router. As in, they will ask this router to proxy on their behalf, so that their work can be done without being required to have an individual public IP address, sort of a thing. So that's basically forward proxy. And yeah, that should be it for this video. I guess in the next video we'll talk about forward proxy and reverse proxy in a bit of details, and how does that work. And there is something called load balancer that I might want to discuss as well, because that comes up on a very day-to-day basis when you are writing code for programs and stuff and everything, like when you're designing a backend and stuff. So that normally comes up, so we might talk about that as well. So yeah, that should be it for this video, I guess. And yeah, see you guys, bye.